Hello, I'm Shankar Guha. In order to predict the future, we need to know what's already happened. Let me give you an example. I haven't told anyone I'd be here right now, but my phone is sending signals to my Facebook page. Security cameras on the streets have detected me on my way here. And my bank has sent me a text message confirming I've withdrawn cash from the ATM around the corner. In other words, if someone is looking for me, they can find me quite easily. And it's not just me, by the way. Chances are you're just as trapped. If you're digitally connected, and most of us are, you have few secrets. Every step you take can be tracked. How long you stay somewhere and who you're with has all been noted. Jealous partners, celebrity stalkers, and private detectives aren't the only ones who are thrilled by this information. For scientists, this data is a gift, offering huge possibilities for research.
Albert László Barabási, a Hungarian scientist based in Boston and Budapest, is a world authority in network science. His discoveries have inspired research in numerous other fields, such as pharmaceutical drugs, social networks, and corporate restructuring. His recent book, Bursts, investigates whether universal laws or principles underpin all human behavior, and if such principles do indeed exist, what use are they to us? Is it possible, for example, to use these laws to work out what any given individual will do in future? Ivan Vitaris, singer of the rock band Ivan and the Parasol, is idolized by his fans. His daily life is a hectic mix of concerts, recording sessions, press conferences, and of course, his private life. However, his popularity has its downside. Pretty much everything he does, 24/7, is of interest to his fans.
Meet Erica and her partner Tom. They first met at one of Ivan and the Parasol's concerts and have been inseparable ever since. So they responded eagerly when a competition was announced on the band's website. The prize is to join the band on a live radio show and later to party with them. To enter, fans have to collect as much memorabilia, specifically objects that have been touched by Ivan, and then send in photos. So Erica and Tom decide to follow Ivan around for a day and collect whatever they can. Ivan is in effect going to be stalked. And frankly, that would make me paranoid. I wouldn't like it. But the truth is, these days, it's frighteningly easy online to follow almost anyone around.
Credit cards, cell phones, social networks, and security cameras all collect and store data about us, which can be used to pinpoint our precise location most of the time. There are also many invisible spies. For example, the latest technology allows all our text messages to be read by satellites orbiting in space. The latest satellites can also produce clear images of objects as small as 41 centimeters across. These images are useful for city planning, scientific study, and also for Google Maps. And Google even has an app called Location History, which can track our precise daily movement. János Kertész is one of the best-known physics professors in Hungary. He's based at the Central European University in Budapest and received the Széchenyi Award in 2014.
Egy tetszőleges napra a múltból
We can easily check when and where we have been on a particular day in the past.
és mikor. Ehhez semmi másra nincs szükség, mint egy Google,
All we need is a Google account, a Gmail address, and a smartphone.
egy Gmail cím, és egy telefonra, hogyha ez...
Having all these with us at all times allows Google to track us with surprisingly minute detail. It can tell exactly when we left our home, where we went, and how much time we spent at a particular place.
Töltöttünk ott, és így tovább.
Of course, all this information would be invaluable to Erica and Tom, if only they could access it. What they don't have in technology, though, they make up for in persistence. Shortly, Ivan will leave his home. All they need to do is follow him and collect as many things he touches as possible. They know a lot about Ivan's daily routine, including his timetable of classes at the university. At all points, they're ready to pounce and add items to their collection. The information they're gathering is similar to the kind of data scientists find useful when studying patterns of human movement in depth.
So Lars, I mean, we tend to make most of our travel bookings now online, and there must be a huge pile of data adding up about how people move. But when you analyze that data, does it tell you anything?
It certainly does. So first of all, we tend to think that we have free will, and to a certain degree we do, which means that we decide what do we do next, where do we go next, and so on. But what this huge amount of data really shows up is that beyond free will, there are very particular patterns that we follow on a daily basis.
The first step for researchers was finding ways in which to source the relevant data. Dirk Brockmann is a theoretical physicist, currently at Humboldt University in Berlin. He's best known for his work on computational epidemiology and a study investigating the geographic circulation of dollar bills in the United States.
So at that time, I was working on the spread of infectious diseases or epidemics, because it's only a matter of time when there will be the next pandemic, and they come, at regular instances, and I wanted to understand and predict pandemics. And in order to do that, we need to understand human mobility. Because of human mobility, viruses are being transported from one place to another. So I wanted to understand mobility. And in that context, I came across where'sgeorge.com, the money tracking website.
So what exactly is where'sgeorge.com? Well, here I have a dollar bill I was given as change in the subway station. Soon I'll buy a hot dog with it, and the hot dog vendor will pass it on next to another customer who happens to be on his way home to Florida. This is how money travels, person to person, state to state. Where's George simply follows the money. Once the dollar is stamped, whoever is the latest owner can look up the travel history of their bill and register its new position. So, a hot dog, please.
When we looked at the dollar bill data, millions of individual dollar bills that moved around in the United States, we found that most of them didn't move much and stayed in one location. And very few of them moved very long distances. For instance, one record bill moved more than 6,000 kilometers. And when we looked at this closely, we saw that these movements of individual dollar bills could be described by something that is known as Levy flights. Levy flights are random motions in which every step is very small, and then every now and then there's a long step.
So among the bills registered on the Where's George site, there are a few untypical ones whose pattern of movement differs hugely from the others. If I was being tracked, I too might appear to follow a freakish pattern, as I travel a lot for my work. For example, just now I tried to pay for a meal in a cafe here in Budapest with my credit card. The transaction was declined because my bank can see that a few hours ago I used my card on another continent, and they clearly don't approve of my unpredictable travel pattern. Tracking dollar bills, quite good fun as a pastime. Does it tell us anything more profound?
Oh yes, it does, because at the end, viruses like Ebola and influenza are carried by humans. And if we want to know where the virus spread, we need to understand where humans go. And the dollar bills always go with us. Whether we take modern transportation and travel on another continent, or whether we actually just bike or walk to the next neighborhood, we carry our money with us. So if I track your money, I'm tracking you.
So like all good detective stories, follow the money.
It's always.
If there was a Where's George site in Hungary, and Ivan enjoyed tracking where his money ends up, this cafe is where he'd be spending a good proportion of his stamped banknotes. It's his favorite hangout. And yes, his fans know that too. Erica and Tom are here, of course, and Ivan is beginning to suspect they're following him. It's the third time he's seen them today, and he's getting a bit fed up with being stalked. So he decides to give them the slip.
Professor Brockmann's discovery about the distribution of dollar bills is at odds with previous theories about how things move around. His conclusions didn't correlate with the findings of many leading scientists who'd studied the patterns of physical movement over hundreds of years. Newton, for example, suggested that mobility is highly predictable. So, with gravity, what goes up must come down on a predictable path. Later, botanist Robert Brown noticed that grains of pollen that fell onto water never seemed to rest, but moved back and forth. This mysterious phenomenon caught Einstein's attention, and he began researching it in 1905.
A Brown mozgásnál a
Brownian motion is the random motion of pollen particles suspended in fluid resulting from their collision with the molecules in the liquid. The movement of the pollen particles hence become random. The same thing happens when we place a drop of paint into liquid. The paint molecules diffuse in the host material. The principle behind this theory originates from Einstein.
Arguably the greatest change in our lives over the past 100 years is how we've begun to generate vast amounts of digital information about ourselves. All possible due to the exponential growth of computers that can collect, store and analyze such data. In Ivan's case, if we want to work out where he's going next, all we have to do is take a quick peek at his social media pages.
Due to Ivan's hectic lifestyle, it's often difficult to guess where he'll have lunch. Today, he's off to the little town of Szent Endre, near Budapest, to see an exhibition. Eric and Tom had lost track of Ivan and were clueless where he might be heading next. But Ivan obligingly posted a link to the exhibition on his Facebook page. Eric and Tom were quick to catch a train to Szent Endre, sadly arriving too late to catch their hero at the exhibition. But the trip wasn't wasted. They got hold of Ivan's entry in the guest book of the gallery.
If humans would behave as randomly as atoms bump into each other in a liquid, then most of our emails would be written at roughly equal time intervals. The dollar bills would follow the same pattern too. They would go in and out of our pockets at roughly regular time intervals. The measurements show otherwise, however. They indicate that the dollar bills change hands very fast, going from one person to the other, and then occasionally get lost in someone's pockets for weeks and months at a time. In other words, the dollar bills follow bursts. The random collision of atoms is best described by a Bell distribution. Most events take about the same amount of time. Dollar bills and human behavior follow a tower law distribution describing bursts, many short events coexisting with a few long ones.
These bursts characterize all forms of human activity, including the way we behave in crowds. Scientists study filmed events and models to analyze how masses move around and how that affects individuals within the crowd. What they learn can be applied to planning big gatherings, such as music festivals.
Coming up after the break, a traffic jam. Do you hate them as much as I do? Traffic on the internet can also be a nuisance, slowing connection speeds to a snail's pace. Can it be controlled? And would you permit a chip to be implanted under the skin of your child, so you know exactly where they are at any given time? We'll have some answers when we return.
Welcome back. We're still talking about Bursts, the latest book by Professor Borobashi. Now, have you ever found yourself in the middle of a large crowd and felt helpless? In the event of a bomb threat or fire, panic can set in, and people have been known to be crushed or trampled to death. Well, using data on human movement, researchers are building models on how to avoid precisely such panic-induced disasters. We'll be speaking to one of the leading experts on the subject very shortly.
A large and unruly crowd is a powerful force, and being within it can be dangerous. If there's a panic suddenly, there might be a stampede, and people within the crowd can get hurt, or worse, be crushed to death. In 2014, for example, at the Sziget Festival here in Budapest, there was a sudden surge in the crowd and almost 20 festival goers were injured. There was a much more serious accident at an English football match between Liverpool and Nottingham Forest in 1989. When 96 people died in the infamous Hillsborough disaster.
In Hungary, the majority of research into mass movement is carried out at ELTE in Budapest, under the supervision of Széchenyi Award-winning professor Tamás Bicek.
Ha megszorul a tömeg, és
It frequently results in tragedy when a crowd gets stuck because the people in the back will push the ones in the front with such force they might suffocate, start to panic, and of course cause more trouble by trying to escape.
pánikba kerülnek, a pánikból persze menekülni próbálnak, de segítséget.
However, simulating the situation beforehand by a program might help. These computer simulation programs show the locations where the crowd is most likely to break into panic and where the pushing force will be the most lethal. But can also show the directions the crowd should be guided in, for example, by cordons, to places where the chances of being crushed are lower. These cordons can also decrease the pressure coming from the people in the back.
Kompenzálni tudják.
Wherever we go, our money goes with us. So in order for these jumps to happen, our banknotes must hitch a lift with someone who travels further than the average person. Here's an example. Just 2 weeks ago, Ivan's band played the South by Southwest Festival in Texas. The dollar bills in Ivan's pocket made a very long journey back to Ivan's home here in Budapest, making both Ivan's and those dollar bills' behavior typical examples of bursts.
Bursts are not limited to human behavior. We see them in the wide range of natural phenomena. The fact that animal behavior, like the flight of albatrosses, follows the same pattern indicates that they are not the result of modern technology. They are rooted deeper than human consciousness.
Gene Stanley is a professor at Boston University's College of Physics. Hundreds of his papers have been published in scientific journals.
The measurements on which basis we work show that when the albatross are over water, that means when they're fishing, and when they're in a dry area, that means flying. It very quickly became apparent that these signals are in no way regular. The water bursts are broken up by long dry periods, and the birds find a place with a lot of food, stay there until the food runs out, and then move on. This is closest to a power law distribution, and in fact matches the levee flight pattern.
When it comes to dollar bills and studying where they go, are there limits to what you can learn from their movement?
Oh, absolutely, because you see, the dollar bills really don't follow you or any other individual. They go from pocket to pocket. So what we really get from a dollar bill is an average pattern of mobility across the population. Now, to truly understand viruses and truly understand human mobility, I want to know where you go. At the beginning, when we tried to do that, I actually was wearing a big GPS watch that would be on all the time and would record my trajectory. Well, we have to be smarter than that. We have to do it for millions of people.
Ivan doesn't have a GPS-enabled watch, but he's carrying his smartphone. His keenest fans are well aware that he likes to run every day. And because he uses an application called Runkeeper linked to his Facebook page, they know where he runs and the distances he's covered. The application suggests he usually runs on Margaret Island. So Erica and Tom station themselves expectantly on his usual route and wait.
However, Erica and Tom are out of luck. Ivan is not following his usual routine today. He's over at his girlfriend's place and has decided to jog in a park in her neighborhood. Because he's broken his normal pattern of behavior, it's almost impossible for Tom and Erica to track him. Eventually, his Facebook page reveals his whereabouts, but the couple were waiting in the wrong location and missed their opportunity. They decide to head for the radio station anyway, where the winners of the competition will later join the band. Time is not on their side, though. They need one more object touched by Ivan in order to win, so they haven't got a minute to waste.
To really understand human mobility, we had to go beyond my personal experiment and understand the mobility of hundreds, potentially millions of individuals. Mobile phones provided the right technology for that. Indeed, every time we make a call, our phone connects to the nearby tower, which must be recorded by our mobile provider. That provides our location with 1 to 10 kilometer uncertainty. As we carry our phones everywhere we go, this data provided for the first opportunity to track the mobility of millions of individuals.
Marta Gonzalez is an associate professor at Massachusetts Institute of Technology in Boston. She analyzes vast data sets on human activities and uses them to formulate models on the underlying patterns of human behavior.
With the help of data from a mobile phone service, we analyze the mobility of hundreds of thousands of individuals. Unlike the where is your data, this allows us to reconstruct the individual mobility. We found that often people move only a couple of kilometers between phone calls, and sometimes they move hundreds of kilometers. So here we could look for birds.
In the modern world, this isn't an unusual pattern. For example, this morning when I was at the airport in London, I called my girlfriend. Later the same day, after flying to Budapest 1,700 kilometers away, I called her again.
In any one cases, you can draw a circle, but there are enormous differences between people. Then, these circles show a power law distribution in relation to one another. So the dollar bills, in fact, move like a levy flight. But people did not move like a levy flight. What happened is that the dollar bill would go from hand to hand, and in exceptional cases, it would come to those people that move long radius. Then it would travel long distance all of a sudden.
Knowing the patterns of people's movement is very useful when it comes to planning road networks or energy grids. For example, a traffic jam is a burst in which a large number of people try to go in the same direction simultaneously. Knowing the behavior of traffic helps planners to control the worst effects of jams.
We are able to identify those neighborhoods that are using the most congested streets. Then we know where they are, and then we try to reduce vehicles in those particular neighbors. That allowed to reduce travel time for everyone. So only targeting 1% of the cars, we reach 16% of travel time reduction. In the future, this research could help for car sharing applications. Imagine an application, a web application such as Facebook, in which people could connect for all the trips that are about to occur. The results are less cars in the streets, less traffic, and cities that are much more livable to all of us.
With the help of apps like Google Maps Traffic, we can all take advantage of modern technology to spot potential snarl-ups ahead and find an alternative route if possible. Eric and Tom use this app after missing Ivan on Margaret Island. They make their way to the radio studio where Ivan's band are expected this evening. By avoiding traffic, they get to the studio quickly, and being early, Erica catches Ivan on his way into the radio station and is rewarded with an autograph. Ivan does a double take. Is this the same girl he's seen so many times throughout the day? Peter Rupert is the CEO of Maven 7 Americas, a business consultancy. One of his projects with his team has been to analyze patterns of human mobility to help fight the spread of HIV.
For example, in Africa, we had a situation, and it was very interesting to see that we were allowed to access mobile data sets. So we used that information, and it also includes information on location, on the cell information where people are located. So we were basically looking for influential people in that given society to address them with information and promotional material on circumcision, and to make them do this approach, because if you do circumcision, then up to 75% you reduce the risk of being an AIDS virus holder.
This information can be useful in many aspects of life. Radio frequency chips are used widely. In Hungary, these chips are embedded in student IDs. Students use the ID cards on public transport and for getting into school premises, but it also makes their movements traceable. In America, they're thinking about taking this technology a step further. There's been talk of transdermal chips to replace PIN codes on bank cards. Such chips could also be used to store personal health data. But conspiracy theorists and civil rights activists are deeply disturbed as they feel this development would allow their government to spy on citizens. And many people are horrified by the idea of a chip inserted underneath their skin. But the fact remains, no matter how much we resist such changes, the vast amount of data collected about us increases year on year.
This becomes all too apparent to Ivan the moment he enters the radio studio. In front of him is a collection of familiar objects. Some of them he threw away earlier in the day, others he touched at some point. And next to them are the by now familiar faces of his stalkers, Erica and Tom. Ivan's surprise is genuine. His band organized the competition as a prank without telling him. While Ivan absorbs how much his privacy has been invaded, Erica and Tom are grinning from ear to ear, having won the competition and their prize to party with their heroes. Since the beginning of this program, you may have been shocked to learn how accurately human movement can be tracked. Whether we like it or not, if we're digitally connected, we're constantly giving away information about ourselves. What movie you're watching, what you're eating or reading, and your exact location at any given moment. It's all out there. You have very few secrets. With so much data at their fingertips, scientists like Professor Borabashi say they can predict your future movement to 93% accuracy, which many of us find frankly scary. In the next episode, however, we'll meet a man who doesn't conform to these rules. He's come to the attention not just of scientists, but the FBI. We'll find out how he managed to outwit those who would like to know all our secrets.